Hello everyone, this is Bart. Today I would like to show how to set up Virtual TemCon for multiple shots per hole and multiple holes per grid square acquisition. When you start Virtual TemCon, it defaults to the basic settings, and this resembles the electron microscope control panel. The F here means that it can stay on the front of whatever other window you overlay to it. So for example, if I now maximize my remote desktop and have this F parameter set, then my virtual TemCon can stay on top of it. Maybe I explain the setup here. So we've got the Gatan K3 computer connected to the JEOL PC on the same network, and then I log into the JEOL PC via remote desktop. So this way I can see both screens on one computer via one team viewer, because this is a remote connection. Right, so let's focus on Virtual TemCon. The basic settings is quite self-explanatory. It looks similar to normal TEM control panels. It also has this control pad here where you can use your mouse to move the beam. This is quite handy if you work remotely and you just don't have access to the normal control knobs. What we will find interesting, however, is the server and the shots and holes tabs. Maybe let me start from the beginning. Let me close this one. And let me start it from scratch. I have it pinned to the taskbar here. However, if you want to start your VTC, make sure that you always run it as administrator, or you set the property here to run this program as administrator. Otherwise, it will be unable to connect to the microscope interface. So here we go. It starts. It says that it's ready to work. This is great. The next thing to do is to go to the server tab, and here we need to set the IP address for our Gatan PC. In this case, this is 172.17.41.2. If you don't know what this number is, go to the command prompt and type the ipconfig command, and here you will see the interface. Of course, you can have many connections, but the microscope network, the JEOL network, is the one starting with 172.17.41. So it's really the question about this last digit. Once you have it, then start the server. And right now, VTC is ready to communicate with SerialEM. Right, one more thing to check. In the JEOL VTC call folder, we've got the VTC call executable, and we have the text file. We need to make sure that the IP address here in the text file is exactly the same as the IP address on the server tab. So they have to match because they talk to each other. The port number can stay. You don't have to change it. Now, let me show you an example of how to use VTC. Well, similarly to Python, to the previous original JAFIS, we can use run in shell, and this is, well, this will work. So we can say run in shell, then we can say C JEOL VTC call exe. Yeah, that's what it is. And then, for example, we may want to say report CL3, which will put the value of the CL3 lens into a text file. And if sorry, there is a typo here. Run in shell. That's what it is. Yeah, and then we can see that it's exited with 0, and then we get the CL3 value written here into this text file as a decimal and hexadecimal number. So we can use it that way. However, when we tested it in Osaka with Makino-san, we realized that this is actually quite slow. Run in shell takes a huge toll on the throughput. This is because Windows take a long time to display the command prompt, and there is nothing we can do about it. However, new SerialEM does have the run process and next process arguments commands. I just copy them from here and I put them here. The way we do it is first we define the new next process arguments, and in this case this will be the argument, so report CL3. And then we can say run process, and then we need to provide a path to the executable. So this is the executable. Now, if I run this one, you don't see any Windows prompt window appearing, and this is much faster because it doesn't need to display anything. It just does the work in the background. So I recommend people use this approach. And what I did here is basically I framed it into a function that takes a text argument, sets this argument as the next process argument, then runs the process, and then it also checks the returned code. So if VTC call works fine, then it should exit with 0. If it's not 0, usually 42, it means that there was a problem. Either the command was incorrect or it couldn't establish the connection. But you don't have to do it. You can just use these two functions to communicate with it. Okay, so let me now show you the setup. Let me now show you the setup, how I would do it in the quickest way. So if we go here, we can see that we are on Carbon. Let's reduce the mag to a mag that allows us to see the holes. For that, I've got to spread the beam, and again, I can use Virtual TemCon for that. If I go to Basic Settings, I increase the step size using the slider, and then I can use my mouse wheel here to, you see, shrink or expand the beam. So I just position my mouse over the knob, I hover over the knob, and then I use the knob, the mouse wheel, to scroll. I may also want to center it a bit. This axis is inverted, so I just have to flag it. Here it is. And then I expand the beam. I go beyond parallel illumination. And this mark is still too high. I probably need something around 6 or 5K. Yeah, maybe 5. Where is it? Here, float, and let's expand the beam a bit. And the angle is at 2. That's not great, but should be still okay. So let's have something like this, and let's now go to SerialEM and let's take a picture. For the sake of simplicity, I'm not going to use the low dose mode in SerialEM. This is so we can do things slowly and maybe focus on the stuff that is important. Okay, so we've got a picture. Then I would center on a hole, and I would take another picture with SerialEM. Here we go. And then I would make sure that the image shift applied is low. In this case, this is almost 2 microns, so I would probably reset image shift, and then I would take another picture and then center on a hole. But this time I know that the image shift is not huge. It's acceptable. Then I go to Virtual TemCon, shots and holes, and I want to get this as hole 0. So I have to untick this protect box, and I have to get hole 0. Central hole has been captured. This is what I want to see. Goody. Then the next thing is to find holes 1 and 3. So let's look for them. Yeah, so this is, well, we may say that this is going to be my hole number 1. So I just go there with image shift. This is a 2x2 grid. This is why these distances are so huge. Then I get this as hole 1. Okay. Then I set hole 0. I take another view picture. Here it is. And then I need to find where my hole number 3 is. So I know that hole number 1 was somewhere here. So I expect hole number 3 to be somewhere around here. Let's have a look. Yeah, that's my hole number 3. So let's position it, let's center it, and then let's go to Virtual TemCon, untick protect, and get hole number 3. Fantastic, this is done. Then we set hole 0 again, and then we can propagate holes 1 to 3. After we did it, we can display map, and this is our preliminary map. It shows us what's possible. So in this case, let's go maybe to hole number 8, and let's take a view picture. Let's see what happens. And indeed, we are on hole number 8. So this is good. So we've got it. We've got the preliminary alignment right. Using this low mag, so 5,000, for example. In principle, you could do even lower mag. I would just not recommend crossing the mag boundary to the lowest possible in the mag 1 range. So 1,000, 1,000, 1,200, 2,000, these are normally not good because there is a huge rotational component, and this will invalidate the alignment. Okay, having this done, we can get back here. Well, we can, in SerialEM, we can reset image shift, and then we can go to the magnification that we want to use for data acquisition. On this machine, I want to use 50,000. 50,000 because I know that 50,000 gives me around 1 angstrom per pixel, and that's what we need for SPA. So let me increase the mag. So that's 50,000. Okay. What I want to do next is I want to position my hole so I can see the edge in the center. Let me do it. Let me do it with the stage. I just have to figure out the directions in which I need to go. I think that's too much. Here we go. So something like this. Okay, then let's go back to SerialEM and let's take a record picture. Okay, not bad. Let me just check the record parameters to make sure that we're not doing any sort of dose fractionation. I can see that I'm getting only 5 electrons per pixel. This is quite dim. Probably I would need more. So let me increase the spot size. Maybe spot number 3. Here we go. That's better. And I just center the beam again. By the way, this is a new microscope, so some of the calibrations are missing. We will get there at one point, but for now, this is not that important. Okay, so I've got a picture. I've got a picture. It does drift a bit though, but okay, it's stabilized now. Goody. So what I want to do now is I want to center on the top of the hole like that, take a record picture, and then I also want to do two things, fix coma and fix astigmatism. Let me start by fixing coma. I do it using the fix coma by CTF 0111 routine. This makes sure that it collects the full Zemlin tableau. So it does 9 shots and it doesn't use the faster method with 5 shots only. This is to make sure that we're not doing anything stupid. Because sometimes this procedure may fail, we can miss it, and yeah, it's 5 points is good, but only for screening, not for data acquisition. Okay, so it has to do it again, because my coma was above threshold. Well, it happens, that's fine. So here are the shots. What I really want to see here is that the score is quite high. So 0.7, 0.8, these are good scores. It means that we are getting good fit, and the whole procedure makes sense. So this is important. Okay, so that's done. And then the next one we want to do is we want to fix astigmatism by CTF. So let me run it. And here we go. So our beam is now positioned correctly, is coma-free, and is astigmatism-free. The last thing to check is whether the beam is centered. And we can see that it's not really centered. It went to a side. So let me just very gently move it so we can see it. We can see it center. Of course, it's possible to script it, and I encourage you to write scripts to get this done. But for now, just the manual method is a bit quicker. Okay, fantastic. So our beam is coma-free, OL stick-free, centered, and positioned on the top of the hole. So we can go to shots and holes, and we can get hole 0 again. Goody. Now, we click on set hole 1, and let's see what happens on the microscope. It kept the magnification. So it applied image shift and beam shift, but it kept the magnification as it was. This allows you to position the holes in lower marks and then just work with them using higher marks. So this is our hole number 1, 4 microns image shift. Let's see how it looks like. So let's take a record picture. Here we go. So we may want to position it a little bit better, like that. And again, let's take a record picture. That's fine. And then let's try to fix astigmatism and fix coma. We start with coma. And we will see how good or bad this cryo-arm is at angle 2. Well, for now we are getting somewhat okay FFTs, so fingers crossed. But if that failed for any reason, I would have to use the HT wobbler and adjust the beam tilt manually at this image shift. So at hole 1, image shifted, I would turn on the HT wobbler and adjust the beam tilt if SerialEM was unable to measure it. But for now, it works okay. As expected, it had to start the second round at 4 microns. Yeah, we expect quite substantial beam tilt. But I'm glad it's finding the FFT. Also, I did not collect a fresh gain reference, so we do see some artifacts in the FFT, but well, it doesn't stop it, so that's good. Okay, so we have the beam coma free, then we fix astigmatism, and this is done with 1 or 2 pictures. That's done, and as before, we now need to check whether the beam is centered. I will do it here on the fluorescent screen. The beam is a bit off, so I will just center it using Virtual TemCon. So here we go, something like this, or maybe more to the right. My TeamViewer connection quality is not great, but yeah, it should do. Okay, so we've got something like this. Then we get it as hole 1. Super. And then we go to hole 3. So we set hole 3. And we have to do this exercise again. So let's take a record picture. Then let's position exactly on the center of the hole, not the center, the top of the hole. This is so we see carbon in the field of view. Okay, here we go. And then we start with coma. So fix coma by CTF. Okay, so first it does autofocus and then it starts doing the Zemlin tableau. And here the beam tilt is quite substantial. I can see the FFT disappearing at the longer apex. So yeah, but again, this is totally expected at 4 microns uncorrected image shift. Right, so it has to go for the second round. And should be done. It should be done in a few seconds. Goodie. So we are comma free. Then we've got to fix the astigmatism. And this is now done. And then we've got to center the beam. In the ideal case, if our compensators worked okay, we wouldn't need to recenter the beam. But as I said, this is a new microscope and we still have some work to do on it. Anyway, okay, so we've got the beam as we wanted, so we can now get hole free. And it has been captured. Then we set hole 0, and then we propagate holes 1 to 3 again. This time, this propagate is being done at the correct magnification and using holes that have comma and OL stig fixed. So it's possible to extrapolate the change of comma or the change of OL stig as a function of image shift distance. The initial propagation at lower mag was just to get to the correct positions, and probably you could skip it if you knew the vectors. If you use the Osaka framework, it's possible to extrapolate the vectors from lower mag images, for example. I just showed how to do it from scratch. But this next propagate holes being done at high mag has to include OL and comma, OL stig and comma corrections. So this is now done. Now let's display map, and this map now should give us corrected images. Then we try to get to the highest possible, to the most distant hole in the X direction and Y direction. In this case, this is hole number 10. And for hole number 10, we have to do the same exercise. So fix comma. The idea is that if we get hole 0, 1, and 3, when we get hole 0, 1, and 3, we will be, how to phrase it nicely, holes 0, 1, and 3 give you the range of 3 by 3 only. And if you want to stay in this 3 by 3 range, that's fine. However, if you want to use a larger grid, 5 by 5, 7 by 7, or even more, then you really need to measure the two most distant points. This way, we don't extrapolate correction factors from these small distance measurements, but we measure a long distance and then we interpolate within this distance, and it just gives better results. Okay, so here this is done. As you see, the comma was actually quite low. It means that our corrections make sense, but it's good to check these. Then let's do the same for astigmatism. Okay, that's done. And then let's check the position of the beam. Maybe a bit off. And as you can see, the beam shift is the limiting factor here, because we are quite far away. Yeah, so something like this should be all right. Goodie. Then I unprotect the getters, and then I get this hole as hole X. Hole X has been captured, and we now know that in this case X means 10, but Virtual TemCon will remember this. Then the next thing to do is to check the most distant hole in the Y direction. So I will go for hole number 14, which is here. I already see that the beam shift could be better, so let me adjust it. Okay, and then let me get back to SerialEM and let me fix coma and astigmatism. So let's see what happens. Oh, let's try again. So we would need to be here in terms of positioning, and then we need to fix coma. Yeah, the first shot was difficult because on this cryo arm, when the fluorescent screen camera retracts, it causes a bit of vibrations. And we need to include a delay of around 2 to 3 seconds to let the microscope settle. It's something on my list of things to do in the future. But okay, it's doing it, and again, because we corrected coma already for holes 1 and 3 and extrapolated, I don't expect a massive coma here. Yeah, you can see 0.06 and minus 0.9 milliradians. I've seen worse. That's okay. Then we have to fix the astigmatism. So here we go. Done. Then we need to check the beam position. And the beam position is okay. So I can unprotect the getters. I hope so. Yeah. Sorry, it's the connection is quite slow. So unprotect the getters and get this hole now as hole Y. So I now have hole 0, X, and Y, so long distances measured, and I can calculate the correction factors by clicking on the propagate holes X, Y. And then it says done. At this point, we are done with it. So just to test it, we are now at hole 0. This is how our microscope looks like. If I display the map, well, in principle, we will be able to do only 3x3 here because this is R2/2. But let me show you how to do it now from the script. Let's say I want to say loop 9, so we will have 9 shots, and then we call them index. Then we can say 1, 2, 3, 4 hole equals index -1. This is because SerialEM starts counting from 1, and Virtual TemCon and all other programming languages start counting from 0. So we just need to generate 0. And then we can say call function, call VTC, and we may want to say set hole $hole, and maybe take a record picture. So something that simple. And we end loop. And let me run the script and let's see what happens. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this is what is happening here. If we see these 50 nanometers deviation, this is really normal. But what I want to see is that the FFT looks all right. So let me run it again. 0, 1, 2, 3. Fantastic. So this is done. If I run the script, I can also look at a map here, and it actually tells me exactly what VTC is doing. So you can see which hole is currently being imaged with this map. Goody. Okay, so then the next challenge will be to integrate this into your JAFIS scripting, but the logic is exactly the same, so it should be really, really easy. Right, let me show you how to set up positions within a hole. So let's be serious about it. Let's say that our record is here. So let's say my record needs to be somewhere here. Let me take a record picture, and here I can unprotect positions. Well, here in principle this is position 0, so I can just get this as hole 0. Then I would need to go to the hole edge. And unfortunately, right now it moved the stage, which it should not be doing. So let's fix it. Let me get back to my top position somewhere here. And I untick move stage for big mouse shifts. This is because the threshold here is set to something like 70% of the field of view. So let's remember this as hole 0. Then let's say we want to go to the edge. Let's say here. Of course, I would need to check the apertures, beam size, and so on and so on. I'm not doing it right now because, again, you know how to do this, and that's not the point of this tutorial. Okay, so let's have it like that, so we can see a bit of carbon here. And then we go to the shots and holes, the right side, we unprotect the positions, and we get position 1. So that's remembered. And then maybe let's go to the other end. Yeah, so that's the bottom end, so to say. So let's take another record here. Yeah, looks good. So we save it as position 2. And then maybe let's go max to the right. Sorry, to the left. That's the left-hand side. Okay, here we go. So let's say this is now my position 3. Yeah, and then I can go back to 0. After doing this, I have to click on propagate offsets, and then I have to click on propagate holes X, Y again. This will make sure that the same offsets will be applied for every other hole, and also that the corrections will be applied to the positional offsets. That's it. We don't need to do anything else. We just have to change a bit of the logic in the script, because here we need another loop, this time for, and then let's call it maybe ind instead of index. And then let's say position equals $int -1, again to start numbering from 0. And then we have to say call function, call VTC, set position $pos. And then we want to take a record picture. And we want to end that loop. Let's see what VTC is going to do now. I am going maybe to show this one here, and I'm going also to show the map just in a way that doesn't cover the FFT. If I can run. So here we go. That's hole 0, position 1, 2, and 3. Then hole 1, position 0. Tick. 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 And tick. Then hole 2. So once you get the OL stick and comma corrected for the most distant holes, so holes X and Y, you can then set positions in the central hole, and these positions are really just image shift. And because Virtual TemCon already knows how much corrections are required for comma and OL stig, it's able to apply them for these small shifts within a hole as well. So you don't have to calibrate these separately for each position. This is no longer required. So here we are. So this is taking 4 pictures in every hole in 3x3 grid. So that's 36 pictures. Yeah, so that's it really. Yeah, and we are done. So that's it really. If you have other questions, then please do let me know. We can set up an online Zoom meeting or a catch-up, so I could explain more about the functionality of Virtual TemCon. Do not be afraid of it. It has many different options, but you don't really have to use them. If you are interested in JAFIS, you know the old Python-based JAFIS, then in principle, this is all you need. And you should be able to achieve the same functionality that you previously had with JAFIS, but now with Virtual TemCon. Virtual TemCon is supported, it's being developed. As you can see, we add tons of functions here. We also test new things. So this is the platform that we want to move forward. Python and JAFIS are obsolete. They are not maintained, and we no longer fix any bugs there, simply because we can't have 2 platforms doing the same thing. And Python was depreciated simply because it's quite difficult to install, challenging to maintain, whereby here we provide you with an executable that just runs. So yeah, that's it really. If you have any further questions, please feel free to get in touch. I hope this helps, and I'm looking forward to hear any positive or negative feedback. Thanks a lot, guys. Take care. Bye.